lecture, I will solve some problems on speed control of DC series motor. The most repeated problems on speed control of DC series motor. A 250 volts DC series motor takes 30 amperes. It means the line current is 30 amperes. So first of all, you should draw the diagram of DC series motor. So I am giving the supply voltage. The V value is equal to 250 volts. It takes a current of S line current is 30 amperes. When running at 800 rpm, this value is N1. So V is equal to 250 volts. The line current IL1 is 30 amperes and speed N1 is equal to 800 rpm. Calculate the speed. So this N2 value is equal to how much at which the motor will run. If the field winding is shunted by a resistance, that should be equal to the field winding resistance. Okay, so the field winding is shunted by an external resistance. The field winding is shunted by an external resistance. This is RSC and external resistance is so V is equal to 250 volts. Okay, the RSC value he is given as what is this resistance here. Next, the load torque is increased by 50%. So T2 is equal to T1 plus 50% of T1. That should be equal to 1.5 times of T1. The armature resistance is 0.15 ohms and the series field winding resistance is 0.1 ohm. The value of series field winding resistance is 0.1 ohms. Assume the flux produced is directly proportional to field current. Yes, assume that flux is directly proportional to field current. So in a first case 1, without this Rx, IL1 is equal to IA1 is equal to ISC1. Once it will be shunted with an Rx, the Rx value is also 0.1 ohms. This RSC is also 0.1 ohms. The current drawn from the supply is now IL2 and the current which is flowing through armature is IA2. And the current which is flowing through this one is ISC2 and this one is the current which is flowing through this one is, let us say, IX. So we know the torque is directly proportional to flux into IA and flux is directly proportional to series field current. See, in the first case, the same current passes through armature and field. Now it will be different. So torque is directly proportional to ISC into IA and T1 by T2 is equal to ISC1 by ISC2 into IA1 divided by IA2. So if you are drawing separately like this, so two equal resistors. So obviously the two equal resistors, the current, this value is 0.1 ohms and this is also 0.1 ohms. And the current flowing through this one is I1. The current flowing through this is I2. Let us assume the current, total current is I. So I1 is equal to total current into opposite resistance by total resistance. Point 0.1 plus point 0.1, that should be equal to 0.2. Then I got it as 0.5 into I. So if you apply current division rule for this, similarly the current which is flowing through ISC2 is equal to total current is IL2. So IL2 and IA2 both are same, because if you apply KCL at this node, IL2 is equal to ISC2 plus IX. IL2 is equal to ISC2 plus IX, and this value is IA2 now. So IL2 is equal to IA2. IL2 is equal to IA2. So now you can apply current division rule. ISC2 is equal to the total current is now IA2 into the opposite resistance is 0.1 divided by 0.1 plus 0.1, that should be equal to 0.5 times of IA2. 0.5 times of IA2. So T1 divided by T2 value is 1.5 times of T1. Then ISC1 is equal to 30 amperes. And ISC2 is equal to 0.5 into IA2 into the armature current IA1. So IA1 and ISC1 both are same for a series current, 30 divided by the IA2 value. The what is IA2? Yes, IA2 is unknown quantity. So T1 will be cancelled. T1 will be cancelled. So 0.5 into 3. Then IA2 whole square is equal to 900 into 3, that is 2700. Then finally I got it as IA2 is equal to 51.9615 amperes. So now the ISC2 and IA2 both are equal. See here, for this ISC2 and IA2 both are equal. The value of current is now as ISC2 and that should be equal to, sorry, ISC2 that is IL2 and IA2 both are equal. Yes, IL2 and IA2 both are equal, and ISC2 is equal to 0.5 times of IA2. Substitute here, ISC2 is equal to 0.5 times of IA2, that is 0.5, that is a half of this 51.9615, that should be equal to 25.9807 amperes. So calculate EB1 V minus IA1 RA minus ISC1 into RSC. What is supply voltage is 250 minus armature current one is 30, and this one armature resistance is 0.1, and again ISC1 is equal to IA in the first case, 30 into 0.1, then I got it as 242.5 volts. Coming to the EB2 is equal to V minus IA2 RA minus ISC2 into RSC. Substitute the values, 250 minus IA2 is 51.9615 into 0.15 minus 25.9807 into 0.1, should be equal to 239.607 volts. We know that N is directly proportional to EB divided by 5. EB divided by 5. N1 by N2 is equal to EB1 by EB2 into flux is directly proportional to ISC, so ISC2 by ISC1. So the speed N1 is 800, N2 is unknown quantity. The back EMF is EB1 is 242.5, EB2 is 239.607 into 25.9807, that is ISC2 divided by 30. So finally I got it as 912.744 RPM. And these problems are 100% will come problems on speed control of DC series motor. And first of all, is without an external resistance is connected across RSE. This is under normal operating condition. The speed will be 800 RPM. The current drawn from the supply is 30 amperes. One sectional resistance is connected across RSE. The two equal value. The IL2 value is divided equally, and ISC2 that should be equal to 0.5 times of IA2. That IL2 is equal to 2 times this one, and the ISC2 is equal to 0.5 times of IA2. So based on what he has given the hint is only one thing. The load torque is increased by 50%, means that is 1.5 times, and torque is directly proportional to flux into IA, where flux is directly proportional to series current, and substitute that. Then find out the back EMF EB1 and EB2, and after that N is directly proportional to EB by 5. So substitute in the equations. Finally you will get the new value of speed. So the new value of speed you will get. And the note on the next problem. The next problem is the second problem. A 200 volts DC series motor. A 200 volts DC series motor drives a load at certain speed. So at a certain speed, and takes a load current of 30 amperes. Load current of 30 amperes. The resistance between its terminals, is 1.5 ohms. Find the extra resistance to be added in series with the motor circuit. To reduce the speed to 60% of its original value. The speed is reduced to 60% of its original value. Assume that torque is directly proportional to cube of the speed. A 200 volts DC series motor drives a load at a certain speed. So first of all you should draw the diagram of DC series motor. So this is series field winding, okay, and takes a load current of 30 amperes. So takes a load current of 30 amperes. So hence the load current is our armature current. So this is RSC, and ISC is like this. After that, the resistance between its terminals is 1.5. That is RA plus RSC is given as 1.5 ohms. So 1.5 ohms. Find the extra resistance to be added. So now I'm adding an external resistance. So this is I'm adding an external resistance here. What is the value of an external resistance? This is our question. Rx is equal to how much? If the motor speed is decreased to 60% of the original value, that means N2 is equal to 0.6 times of N1. Students, you can remember speed reduced by, so reduced by 30% means, So your answer is 70 percentage. Reduce it to 30 percentage means your answer is 30 percentage only. Okay, and n1 by n2 is equal to 1 divided by 0.6. First of all, calculate the back emf. eb1 is equal to v minus ia1 into ra plus rsc. V is given as 200 volts. The supply voltage is given as 200 volts minus the armature current IA1. The IA1 is 30 amperes. IA1 is 30 amperes into 1.5, that should be equal to 155 volts. So what is the torque equation? Torque is directly proportional to flux into IA, and here I am connecting series, right? Yes or no? Then flux is produced by the field winding is depends upon IA. Finally, I write it as torque is directly proportional to IA square. T1 by T2 is equal to IA1 divided by IA2 whole square. But IA1 divided by IA2 whole square is equal to, so torque is depends upon, see here in the problem is given that torque is directly proportional to n cube, means n1 divided by n2 whole cube, n2 whole cube. Okay, so what is ia1? Ia1 is 30, so ia1 is 30, and ia2, so we have to calculate that yes or no. Ia2 whole square, the speed n1 by n2 is equal to 1 by 0.6 volt cube, 1 by 0.6 volt cube. So if you are expanding this, the finally I got it as ia2 is 13.9427 ampere. So ia1 is 30, but ia2 is 13.9427. So we have a relationship. N is directly proportional to eb divided by 5 and directly proportional to eb by ia. Now n1 by n2 is equal to eb1 by eb2 into ia2 divided by ia1. So n1 by n2, so that is 1 by 0.6. The eb1 value is 155. eb2 is we have to calculate. This is 13.9427 divided by ia1 is 30. Then finally I got it as eb2 is equal to 43.22 volts. Now eb2 is equal to v minus ia into ra plus rsc plus rx. eb2 is 43.22, the supply voltage is 200, minus ia2 is 13.9427, and ra plus rsc is 1.5 plus rx. So from this expand this, then finally I got it as 9.475 ohms. The rx value is 9.745. Coming to this previous problem and this problem, in the previous problem I am connecting the external resistance in parallel with the series field winding. Then the current which is flowing through the series field winding is not same in the case 1 and case 2. Why? Because the current will be divided through Rx, and in the problem is given that the torque is flux is directly proportional to the field current. So torque is directly proportional to flux into Ia, and IAC1 divided by IAC2 is equal into Ia1 by Ia2 is equal to T1 by T2. But in this problem you can observe the 30 amperes current is flowing under normal operating condition. We are connecting an external resistance in series with this motor combination. So obviously, so if you have a simple concept, this 200 volts is applied, 200 divided by, so something you will get suppose something you will get some current, x current, and I is equal to, now in this case same 200 divided by something plus rx, definitely the denominator will be increases, obviously the current will be decreases. The same concept you can apply logically The supply current is 30 amperes in the case 1, but coming to the case 2, the current value will be decreases. So find out find out the Rx by using this method. So thank you guys.